Today in module number 11, we'll be talking about cloud and virtualization security. You might have seen lots of cloud services, and there is a way how we virtualize the infrastructure. So that's what we will be talking about in this module. Now, simply put, cloud computing is like renting your office space instead of buying it. Just as you might rent office space to save on the cost of the buildings you own, cloud computing allows businesses and individuals to use computing power and storage from providers over the internet, paying only what you'll use or the services that you'll utilize. This means that you can access the data, run the applications, and even power an entire business without even owning a single server or a vast IT infrastructure. So that's what we are explaining over here. The cloud computing is a model of enabling a convenient on-demand network access to shared pool of configurable computing resources, because we can configure the network, server, storage, applications, and services, etc. that can be rapidly provisioned and released with a minimum management effort because it is hosted by different service providers. Now, you might have heard of Amazon Web Services, Google Cloud, then we have for Oracle, VMware itself. So there are different clouds, and how can we forget Microsoft and the big names which are providing all these services in the cloud. Now, there could be lots of components of it, but we'll talk about its significance. The model provides a significant benefits such as cost efficiency, scalability, and accessibility, making it an integral part of the IT integration and the business for the individuals. Example could be a small business is utilizing a cloud services to host its website, maybe manage the customer relations, and store the data securely by eliminating the need of large initial investment in the physical and IT infrastructure. So, we talked about cost efficiency. One of the most significant advantages that it would help you in reducing the IT cost. Using the cloud services means that you don't need to invest heavily in the hardware, facilities, utilities, or maybe the building or the large data centers, etc. You'll only pay for the computing resources you'll use, which can significantly reduce the overhead and the capital expenditure. So if we'll talk about scalability, cloud services provide flexibility that is hard to achieve with the physical infrastructure. You can scale your computing resources up or down based on the business needs. This is ideal for businesses to experience fluctuating workloads or those looking to grow quickly without the pain of constant hardware updates and things like that. Then if we'll talk about accessibility, that's another huge benefit that cloud computing would help you and manage your data and applications, and they are available to you wherever you will travel in the world, or provide you that you'll have the internet connections, means that provided that you have an internet connection with you, you'll be able to access all those services from anywhere. This makes it easier for the businesses with multiple locations to remote employees, etc., who are traveling around to stay connected with their head offices, etc. Now, there are different characteristics of cloud services. So first of all, we have on-demand self-services. Users can automatically provision computing capabilities as need without requiring any human interaction with each service provider. So that's one of the standout features of cloud computing, the ability of manage the computing resources like servers, time, and network, etc. Without requiring the human interaction. This means that you can set up whatever you want with the need of a web interface which is accessible anytime, and you can even compute more resources and reduce it as you need. So the example could be a user can log into the cloud services control panel to increase the number of virtual machines during the peak load periods without calling the service provider. Then we have broad network access capabilities are available over the network and accessed through the standard mechanism that promote use of heterogeneous thick and thin clients, for example, mobile phones, tablets, laptops, and other things like that. So it would help you by having the resources when you need it. You can access your data or the application from anywhere, which is particularly useful for the businesses with a mobile workforce or multiple office locations. So employees can access the applications and data through different devices, like if they're using their mobile phones or the laptops, regardless of their location. Then we have resource pooling. The provider computing resources are pooled to serve multiple consumers with multiple tenant model, which is different physical and virtual resources dynamically assigned and reassigned during the consumer demand. So that's why we call it multi-tenancy as well. The customer generally has no control or knowledge over the exact location of the provider and the resources, but may be able to specifically specify the location at a certain abstraction level, for example, country, state, or data center. This maximizes the cost efficiency and scales seamlessly according to the user needs. We can have an example of different companies share the same storage space on a server cloud with the data kept private with each individual companies, and they can securely manage their operations of each company. Then we have rapid elasticity. That's the capability that can be elastically provisioned and released, in some cases automatically, to scale the rapid outward and inward when the demand would increase. So it's a critical component of cloud services that would allow the system to scale the resources up and down quickly. The flexibility can be crucial for handling the peak loads during the business periods without paying an idle resource during the off-peak times for businesses. This means that you can adapt the change in demand without upfront investment or performance penalties. So example could be during a promotional event, a retail website can scale the resources to cope with the surge in the traffic and then reduce the resources after the event is over to save the costs. Then we have measured service. Cloud systems automatically control and optimize the resources by using the leverage and metering the capabilities that of some level of the abstraction appropriate to the type of service, for example, storage, processing, bandwidth, and active user accounts. Now, resources usage can be monitored, controlled, and reported, providing the transparency for both provider and consumer of the utilized resource. You can check everything, resources usage is monitored, and you can easily grow and depute the resources based on your requirements. Then we have different cloud models over here. We call them different types of clouds. There are public clouds, private clouds, hybrid clouds, and community clouds. So if we are talking about a public cloud, the cloud environment created for resources not owned by the end user, available to many different customers over the internet. So we can say that Google Cloud Platform, Amazon Web Services, and Microsoft Azure are the classic examples of public clouds. This model offers high scalability and flexibility without the direct responsibility for managing the infrastructure. It's typically the most cost-effective option as it utilizes a pay-as-you-go model where you can pay for the services you'll use. So example could be Amazon Web Services, etc. Then we have a private cloud. A private cloud is a cloud environment dedicated for a single organization with more controlled access and privacy. So unlike the public clouds, private cloud is used exclusively by a single organization. It can be hosted on premises externally, and while it is often managed and maintained by the organization itself, it can also be off-premise, and it can be managed by the third-party companies as well. The primary advantage of a private cloud is greater control on privacy, making it ideal for the businesses with the high data security, regulatory compliance, and the performance requirements, etc. So a large bank can use a private cloud to host its data to ensure that it enhances the security and control. Then we have the hybrid cloud, a cloud environment that combines both public and private clouds, allowing both data and application to be shared between them. So as the name suggests, hybrid cloud combines the public and private cloud and bounded together by the technology that allows the data and application to be shared between them. This would allow the flexibility, allowing the business to scale up their on-premises infrastructure to the public cloud to handle the overflow during the peak hours, or often referred to as the cloud bursting. Hybrid clouds often is a mix of control and flexibility, providing businesses the ability to manage code-sensitive data internally while also taking the advantage of cloud resources. So a retail company can use a private cloud or store the sensitive data but interact with the public cloud for customers facing operations, etc. Then we have a community cloud. It's a cloud environment shared by several organizations with common concerns such as security, compliance, and jurisdiction, usually managed by third parties and or of the organizations in that community. So a community cloud is a shared between organizations, as said, with similar backgrounds or that require similar resources, regulations, and performance concerns. This type of cloud can be located on premises or off premises and is managed by the organizations or the third-party providers. This arrangement helps reduce the cost while still providing a tailored environment that meets the specific community needs. So example could be several government agencies created a community cloud to manage the data that adheres to the specific regulations and standards. So we have different cloud locations as well. Now, for the cloud locations, the location of your cloud service provider plays a crucial role in how your data is managed and how quickly and securely it can be accessed. So we'll be looking at different cloud locations: on-premises, off-premises, fog computing, and edge computing. So if we are talking about on-premises, it's the cloud services deployed on an organization-owned physical on-premises data center that you would own or your organization would have. So this model would refer to deploying IT infrastructure in-house within your organization and physical premises. Essentially, the organization owns and operates and manages the servers and infrastructure. This setup offers maximum control over the data systems or the servers, etc., typically favored by entities that require strict data control and regulatory compliance. However, it demands significant capital investment, ongoing operation, cost, maintenance, experts, and all those things. So example could be a financial institution can manage a private cloud in its own data center to maintain a full control of the security of the data and its sovereignty. Then we have off-premises cloud services hosted at a third-party location away from the organization physical business locations. So it means that the setup would include traditional public and private cloud services hosted in the provider's data center. This model may reduce the operational burden of the organization and can offer greater scalability and cost efficiency, but at the potential cost of lesser control over the physical hardware. Example could be small businesses utilizes cloud services hosted by providers like Microsoft by reducing the need of extensive on-site IT infrastructure. Then we have fog computing. Now that's a bit relative new term, an architectural approach that brings computing, storage, and networking services closer to the end devices or the edge of the network. So it would involve placing the nodes directly in the network logical periphery to process the data locally before sending it to the central cloud system. This approach can dramatically decrease the latency, increase the efficiency for the time-sensitive data processing, etc., across multiple locations, and support IoT technology by processing of the data by near its origin. So smart traffic lights in a city using the fog computing to process the data locally from the IoT devices to adjust the light change without sending the data back to the central system could be an example of cloud computing. Then we have edge computing, which is slightly different. It's distributed computing paradigm that brings the computational and data storage closer to the location where it is needed to improve the response times and to save the bandwidth. So the idea is to minimize the latency and the bandwidth used by handling the computational on the devices like user computers or IoT devices or edge servers. This can be critical for real-time applications such as those in manufacturing and autonomous vehicles, etc., where sending data back to the centralized cloud server and processing would be a bit slow. So a manufacturing plant usually uses the real-time data for the machinery to quickly identify and address the operations. Then we have different cloud architectural components. So we'll be talking about thin clients, transit gateways, and serverless infrastructure. So if we look at thin clients, these are the low performance computing devices that rely on a server to perform most of its processing tasks. So we can say that these are the lightweight computing devices that rely heavily on a central server instead of having extensive computing resources and data storage capabilities on the devices itself. They run on minimum softwares, operating system, or primary function of the interface is to access the computing resources hosted on the remote servers, typically in a cloud environment. This setup can significantly reduce the hardware cost and simplify the maintenance and security management, etc., making thin clients the attractive option for the organizations looking to optimize their IT resources. So corporate offices uses thin clients connected to the server, which can handle all the computing and storage, allowing the lower cost and easier maintenance, etc. Then we have transit gateways, a network transit hub that interconnects virtual private clouds, VPCs, and on-premises networks. Now think of it as a central location that manages and directs the flow of the data across different networks within the cloud infrastructure. By using transit gateways, organizations can scale their networks more efficiently and reduce the complexity involved in managing the connectivity and routing policies between numerous VPCs and external connections. So example is an organization can use transit gateways to connect their multiple VPCs across different regions to their main data center seamlessly. Then we have serverless infrastructure, an architecture where the cloud provider manages the setup, capacity planning, and server management, allowing the developers to focus solely on individual functions and their applications. Now, anything as a service is another thing, a collective term that refers to the delivery of anything as a service through cloud computing, combining the various cloud services, including software as a service, platform as a service, infrastructure as a service, or more specialized services. So IBM Cloud could be an example of it, which offers a suite of integrated tools and covered data, software platforms, and infrastructure within a single package. Now, if you're talking about everything as a service, that reflects the expanding the breadth of the cloud services now available that go beyond the traditional categories. This can include anything from the network as a service, or we can say database as a service, to near forms like function as a service, or even the blockchain as a service. The idea is that almost anything can be delivered from the cloud, removing the need of the physical or on-premises services. After that, we have cloud management techniques. There are different cloud management techniques, but out of those techniques, there are two which are very common, which is efficient use of cloud resources and optimal cloud service management. So if we'll define it, it's the strategy to maximize the efficiency and resource and utilization in the cloud to reduce the cost. The cost of it, the components could be resource allocation, monitoring, and scaling based on demand. Auto scaling in Amazon Web Services could be an example of it, which automatically adjusts the amount of the computational resources based on the service load, ensuring the proper efficiency use and resources and cost saving, etc. The right sizing of the resources is important because it's one of the steps of the efficient cloud resources, using the right sizing, which means that provisioning of the right amount of the resources meets the performance and the capacity needs without over provisioning the resources. Now, if we'll talk about cost management, it keeps track of your spending on cloud services, which is cost management tools, etc. These tools can help you understand where you're spending money and identify areas where you can save money, perhaps by switching to the different type of services, revealing the instances and the advance, or scaling down the resources when they are not in use. Further, we look at the automation in this one, which will be a common task such as backup, scaling, updates, etc. Automation is not only saves time, but it also reduces the likelihood of a human error. And then we even discuss the performance monitoring, continuously monitoring the resources available. This can also help in maintaining the efficiency of the cloud operations, but also ensures that issues and quickly identifies the address problems before they'll arise and would affect the customers, etc. Then we have optimal cloud service management, the process of overseeing and controlling the cloud environment to ensure the services meet the business and technical requirements. For example, we'll have the service line agreements for that, cost management and security controls. Microsoft Azure Management Portal provide tools for monitoring the resources, performance, management budgets, and configuration settings, etc. for its services. So service line agreements are managed with your cloud service providers, ensuring them that the terms aligns with the business needs and that the compliance and the performance standards are met. So if we talk about integration and configuration of it, the business often uses multiple cloud services from different providers. Managing integration and proper configuration is really important for that. Now, this ensures that your cloud environment works cohesively and meets the optimal demands. Security and compliance is also important, where it would include and identify the access management, encryption, and security audits, etc. And in case of any disaster and recovery, you must have a business continuity plan. So if it's all in place, we make sure that our cloud is very well managed over there. Now, we have different cloud security mechanisms. As the businesses would grow, they'll require there will be a need that they continue to migrate to the cloud, ensuring that the security of the data and application becomes a paramount. We'll ensure that the three critical security mechanisms, which is secure web gateways, cloud access security, which we call as CASB, or the secure access services, etc., are there in order to make sure that we are compliant with the cloud security, etc. So if we'll talk about cloud web gateway security, etc., these are the appliances or the services that prevent unauthorized access to potentially dangerous websites to ensure the compliance with the organization policies by filtering the unwanted softwares, malwares from the user-initiated web traffic, etc. So components could be URL filtering, malware detection, the data loss prevention, and application control. So semantic web services provides the comprehensive web protection by filtering unwanted data and the software and malware from the internet traffic in a real time. As businesses face an increasing threat from the internet traffic, SWGs provide a proactive and dynamic line of defense, ensuring that only secure, compliant web traffic is allowed into the organization. Then we have CASB. They are security policy enforcement points that sit between the cloud service consumers and the cloud service providers to ensure the security policies and cloud-based resources are accessed. For example, its components could be visibility, compliance, and data security and threat protection. McAfee mVision in the cloud, etc., acts as a policy enforcement center, combining the consolidating multiple types of security policy enforcements, etc. Now, its example could be policies that would include authentication, single sign-on, authorization, credential mapping, device profiling, encryption, tokenization, logging, alerting, or malware detection, prevention, and so on. They are particularly useful for organizations that use multiple cloud services who want to maintain visibility and control over the data across different platforms. Then we have Secure Access Service Edge. It's a security framework that combines the network security functions with WAN capabilities to support the dynamic, secure access and the need of the organization, integrating into both networking security services into a single cloud delivered service model. SD-WAN, firewall service, firewall as a service, or zero trust network access and threat prevention could be the components of it. You might have heard of Palo Alto Network Prisma Access. It provides a comprehensive solution that delivers both network security services from the cloud. So we can say that it's a new enterprise network technology that combines network security functions such as SWG or CASB or firewall as a service with WAN capabilities like SD-WAN to support the dynamic secure access which would be needed by the organizations. Essentially, SaaS could leverage the functions into a single integrated cloud service that can be delivered uniformly to all edges. Now, this model is particularly beneficial for the organization with geographically dispersed resources and personnel who require consistent and secure network access regardless of their location. Now, after this one, we are looking at cloud security challenges. There are different challenges which are there for cloud security. First of all, we have unauthorized access. Unauthorized access occurs when individuals gain access to the systems and network without the permission, potentially leading to data theft and the system manipulation, etc. Its implications could be that it can lead to data breach, loss of sensitive information, and unauthorized use of the cloud resources. Now, prevention measures could be to implement multi-factor authentication or rigorous access control policies, etc. Then we have insecure APIs. Application programming interfaces that are exposed to the internet can be vulnerable to the attacks and if not properly configured. So implication could be that it can compromise the security of the software application, leading to data exposure, service manipulation, and denial of service attacks. So before it goes on the production servers, you'll have to make sure that you check all the APIs that they are performing as they are supposed to perform. Preventive measures could be employ robust encryption, ensuring the API are regularly updated, and run the rate of limiting or conducting limiting and to conduct thorough security audits of the APIs. As we know that API can expose the organization to security breaches, data leaks. Attackers can exploit the vulnerabilities of the API to gain control over the cloud services. To combat this, it is vital to implement secure coding practices, regular security testing across the controls to make sure that only the authorized and authenticated services and developers can access and interact with these APIs. Then we have system vulnerabilities, flaws in the weakness in the system that can be exploited to gain unauthorized access to cause harm to the system. Make sure that systems susceptible to wide range of attacks, including the malware, infection, data corruption, and sensitive disruption, etc., are properly patched and checked. Regularly update all the systems vulnerabilities by scanning and things, and we usually do ethical testing or the vulnerability testing within our organizations to make sure that which are the systems in our organization which are quite vulnerable. Then we have cloud security controls. So in order to make sure that cloud security controls are well in place, you'll have to conduct the regular security audit, systematic examining of an organization information systems environment to assess the adequacy of the security measures, etc. The purpose could be to ensure the compliance and security policies and standards, to identify the vulnerabilities which are there. Example could be a financial institution conducts quarterly security audits to comply with its regulatory requirements and improve the security posture by addressing any discovered weaknesses in it. Now, these audits can be conducted internally or by the third-party security firms, typically involve reviewing the system configuration, access controls, and compliance with the security policies and standards. Regular security audits would enable the proactive management and potential security issues before they can be exploited by the malicious actors. So security management, the tools and methods used to manage digital authentication credentials, secrets such as passwords, keys, and tokens to protect the sensitive information. Unauthorized access to manage the lifecycle of the secret securely could be a purpose of it. And you might have seen, as an example, healthcare provider uses HashiCorp Vault to manage and retort the database credentials, ensuring that the sensitive patient data remains secure from internal and external threats. Now, since we talked about exposed secrets, it can lead to significant security breaches. Effective secret management ensures that the sensitive information is encrypted, access is tightly controlled, and usage monitored or audited. So we have different tools for that. As we mentioned, HashiCorp Vault or Amazon Web Services Secrets Manager or Azure Key Vault, they provide a robust solution to help manage and rotate the secrets accordingly and the best practices, etc. Then we have enforcing the functional area mitigation, implementing the specific security measures tailored to particular functional areas within an IT environment. This purpose could be to address the unique risk associated with the specific segments and its IT systems, ensuring the overall security. Example could be an e-commerce company implementing additional encryption across its payment gateways to make sure that there is no risk of any sort of financial fraud. So it means that in ensuring a functional area mitigation, it also means that applying the appropriate security controls like network segmentation, encryption, access policies specific to the need and security requirements of each area. This targeted approach would help effectively reducing the vulnerability across various components of the cloud, etc. After that, we have virtualization, which is very important because whenever we would like to set up an infrastructure where we'll have virtual servers, the key technology that would drive the efficiency and flexibility of the IT environments would be virtualization. It would allow the creation of the virtual machines of physical hardware, leading to more efficient utilization of the resources. We'll cover the basics of virtual machines, hypervisors, both type 1 and type 2 containers, and VDIs, which is virtual desktop infrastructure. So let's try to see what is a virtual machine. A virtual machine is a software-based emulation of the physical computer that runs on an operating system applications, and it would be like a physical machine. So you might have used VMware Workstation or Oracle VirtualBox, which is used to run multiple operating systems on a single hardware or a single machine, but for testing purposes, etc. So virtual machines are isolated from one another and from the host machine, providing a secure and stable platform for running different applications and operating systems on the same physical hardware. This isolation ensures that the processes in one VM do not affect the others by enhancing the security and stability across the systems. Then we have hypervisors. We have both type 1 and type 2. Now, hypervisors are also known as virtual machine monitors or to manage the virtual machines. Type 1 hypervisors usually run directly on the host hardware, so that if you have installed a software like virtual machine VMware Workstation or Oracle VM VirtualBox, this is a type 1 which runs on the type 1 directly on the host hardware. You might have seen the VMware appliances, which are the hardware devices which is own operating system, with the help of which you can manage the virtual machines. So we call them as type 1. Whereas type 2 hardwares are the kind of example as we gave earlier, like VMware Workstation, etc., on which we'll install a software, and using that software we'll run the virtual machines. So type 1 is VMware XaaS installed directly on the server hardware without requiring any additional or underlying operating system, whereas on type 2, VMware Workstation that runs conveniently on the operating system like the Windows and Linux, etc. So if we'll sum it up, type 1 hypervisors run directly on the host hardware to control the hardware and to manage the guest operating systems. For this reason, they are called the bare metal hypervisors as well. It would include VMware Workstation, XaaS, Microsoft Hyper-V, and Xen, etc. Then type 2 hypervisors run on the host operating systems that provide virtualized services such as input and output devices support, that support the memory management, that are often referred as hosted hypervisors because they are dependent on the host machine operating system. Popular examples could be VMware Workstation or Oracle VirtualBox. Then we have containers or containerization. They are the used for virtualized operating system, allowing you to run multiple workloads on a single operating system instance. They are more lightweight and start faster than the virtual machines. Docker is a perfect example for that, where it enables the developers to package applications into containers, standardized executable components combining the application resources and the source code for the operating system libraries depending on the required to run it as a code in the environment. So VM, like in the containers, virtual machine virtualize the entire operating systems. Containers virtualize only the application layer. A container contains the applications and all dependencies, but shares the operating system with the kernel and other containers. Now the containers are lighter, as mentioned earlier, use the fewer resources than the virtual machines, and it would start much faster than a regular virtual machine. This makes them the ideal environment where the high demand is there. More density, scalability, and speed is the priority. Popular computerization or the containerization platforms include the Docker and Kubernetes. Then we have the VDIs. This is a technology that hosts the desktop environment on a central server and deploys them as the end user. So Citrix Zen Desktop provides the VDI solution that allows the IT departments to deliver and corporate desktop uses to any device anywhere with maintaining the security and compliance. So it's a form of desktop virtualization where desktop environments are hosted on a central server and delivered over the network to end users. Now, VDI allows users to access their desktops on any device from anywhere while decentralizing the management and security of these desktops. This setup is particularly beneficial for large organizations and remote work environments, offering a consistent and controlled user experience across wider range of hardware. Now, if we'll continue to the advantages of virtualization, there could be lots of benefits of using virtualization. First of all, we have resource optimization. Virtualization allows for dynamic allocation and reallocation of the resources based on demand maximization and utilization of resources. So example is server consolidation, for example. Multiple servers roles and are virtualized into a single physical server, significantly reducing the underutilization and saving the hardware cost, etc. So for the resource optimization, it can lead such as we can allocate the resources, CPU and memory resources that might otherwise remain idle can dynamically be allocated where they can be used till its maximum capacity. This maximizes the efficiency and can drastically or dramatically increase the capacity of your existing hardware without additional investment, etc. Then we have increased flexibility. Virtual environments can be easily configured, copied, and moved, provided the operational agility and the physical setup cannot match, etc. So deployment and testing, developers can quickly spin up the virtual machine as instances to the test applications and update without affecting the production environment. So as we know that with virtual machines and containers, IT administrators can quickly scale up and down the resources according to the demand, deploying the new application, testing environment, operating system environment without risking the underlying physical setup. The agility can make it easier for the organization to adapt to changing business needs, to the technological developments. For example, a company can have virtualization to provide customized set of applications and resources for different departments and projects quickly and with a minimum fuss. Then we have cost reduction. In cost reduction, it reduces the need of physical hardware, lowers the power consumption, and minimizes the requirement of the physical space, leading to significant cost savings. For example, for the data center cost, by using the virtual machines, companies can reduce the number of physical servers, lead to lower energy consumption, and reduce the need of the space of cooling and data centers. But don't forget the cost associated with the experts who will be required, who are a specialist in managing the data centers and the servers, constant updates, their licensing, and all those other things could be reduced if you are going for virtualization. Then we have infrastructure as a code. So first of all, if we'll define infrastructure as a code, it's a key practice in the DevOps philosophy that involves in managing and provisioning the computing infrastructure through the code instead of through the manual processing. With infrastructure as a code, entire infrastructure can be defined, deployed, updated, versions with the same control and precautions as a software. So infrastructure as a code tools like Terraform, Ansible, and Amazon Web Services, Cloud Formation, etc. allows the developers and IT teams to automate the setup and maintenance of the environments, ensuring consistency, accountability, and speed of the infrastructure deployments. This method drastically reduces the potential of the human error and enhances the scalability of the environments. So that's why we have software-defined networking, the approach in the network management that enables the dynamic, programmatically efficient networks, configures and improves the network performance by monitoring it. Cisco application-centric infrastructure could be an example of it, which simplifies and optimizes and accelerates the application deployment lifecycle within data centers. So SDN always enhances the network flexibility and makes it easier to deploy new services, reduce cost, and improve the network management and performance, etc. Then we have software-defined wide area network, SD-WAN, a specific application and technology that is applied to WAN connections, which are used to connect enterprise networks or large geographical distances. So example could be VMware SD-WAN by VeloCloud. It offers the flexibility, scalability, and reliable WAN connections by improving the bandwidth efficiency and ensuring the optimum performance and high priority applications. So we can say the SD-WAN is an extension of SDN that applies these principles to wide area network. SD-WAN solution transforms the organization's connectivity approach across different locations such as the branch offices and data centers to improve the network efficiency and performance. They also allow the enterprise to route traffic across best available network paths, optimize the cloud connectivity, and ensure and enhance the resilience of the automatically adjusted to the network conditions. SD-WAN is particularly beneficial for businesses with the geographically dispersed operations, providing more agile, cost-effective, and alternative to a traditional WAN technology. Then we have software-defined visibility, SDV. It extends the concept of SDN to network visibility and monitoring, allowing the enhanced management and analytics of the data traffic across the network. Gigamon visibility and the analytics fabric is an example of it, where it provides the pervasive and the visibility across the public, virtual, and cloud infrastructure, enabling the enhanced security and monitoring capabilities. So SDV emerges as a concept of building on the idea of software-defined networking to provide deeper visibility into the network application performance. SDV tools help the administrators monitor and manage the network traffic more efficiently by providing the insights into the data traveling over the network. This level of visibility is crucial for security, performance monitoring, and troubleshooting, ensuring that the networks are not only efficient but are also secure. Then we have different security concerns in a virtual environment. And if we look at it, we have two things, which is specific vulnerabilities or security strategies for virtual systems. So if we look at briefly on specific vulnerabilities, so they tell us that there are certain unique vulnerabilities to the environment, such as hypervisor vulnerabilities, inter-VM attacks, and the virtual network security. We'll talk about it in a minute. But then we have hypervisor security. This is a strategy to implement robust access across patch management and secure the configuration to protect the hypervisor from any sort of attacks. So if we'll understand the specific vulnerabilities of the virtual machines, it could be, first of all, VM escape. This is one of the most crucial vulnerability where the attacker gains access to the host virtual machine from within the virtual machine. This breach could potentially compromise all the virtual machines which are running on the same host. Then it could have a problem of insecure APIs, where the virtual environment can often managed through the APIs. If any of those APIs is insecure, they can provide attacker with a way to control the virtual machine and manipulate the virtual environment. Then another thing could be a snapshot of the image flaw. Virtual machines can be served as a snapshot or the images, which can contain sensitive information. If the attacker access these snapshots, they could recover the sensitive information or even clone the fully functional virtual machine. Then the last thing which could be there in a specific vulnerabilities could be hyperjacking. That would involve the attacker installing rogue hypervisors to take control of the host machine, and that can particularly be dangerous because it allows the attacker to control all hosted machines. Then we have another thing, which is security strategies for virtual machines. In this one, we have comprehensive approach for design to address and mitigate the risks which are unique to the virtualized systems. It could be segmentation and isolation strategy could be there. You can use the network segmentation for micro-segmentation to isolate the workloads and minimize the lateral movement. Then intrusion detection and prevention systems could be deployed that are capable of monitoring these proactively in the virtual network traffic and regularly audit, and the compliance checks, etc. could be introduced, where it could conduct the regular security audits and compliance assessment to ensure the virtual machines and organizations for their security policies and standards. So Likewise, as we defined it first, we look at some other things which could even fall under the security strategies of virtual systems. It could be robust access control, implement strong authentication and authorization practices to limit the access of the virtual environments. You can use multi-factor authentication for least privilege and access to minimize the risk unauthorized access. Then you can have regular patch management to keep the virtual machines up to date and latest for any sort of security, and the patches should be applied. This could include not only the hypervisors but also the guest operating systems, applications, and the components of the virtual infrastructure. You can do the network segmentation, monitor and merge the virtual machine sprawl. That's very important to keep a track of all the virtual machines and ensure that they are adequately secured. Unused and unauthorized virtual machines should be decommissioned to avoid becoming an easy target by the attackers. You can encrypt the sensitive data. So by encryption, you can protect your data at rest, data in transit, and in the virtual environment. This can prevent the data breaches even if the security measures are bypassed. And in the end, as discussed, that we can implement intrusion detection and prevention systems, etc. So that was our lecture on cloud and virtualization security.